Okay, starting on part 4 of this video series, and I wanted to kind of document what I have found after replacing that bad 85, which I put in here, LS85, this guy right here. After replacing that, I believe I have found what that thing is responsible for. And I believe it is responsible for the movement of the road. Maybe? And like the road doesn't seem to move. I don't know. But if I start the game and I'm wiping out, I don't know if I shorted something, or let's restart this thing. Okay. Okay, something don't look right. Something ain't looking right. What did I do? There we go. I don't know what. Maybe I was pressing on something. But you see, the road don't move. Is it not supposed to move in a track mode? Because it doesn't now. But if I start the game, it starts moving. And when it's game over, it will no longer move. It stops moving. Yeah, I believe it takes like 90 seconds or whatever the thing is set at to time out. There's Crazy Blue. Yeah. Yeah, and once this game ends, you'll see it just it stops moving. The road will stop moving. I think I'm going to have to check out this game once again, and maybe I'll pop that I'll pop that 85 back in and see if it continues to move like that when the game is over. There's Crazy Blue. Any day now this thing will time out and the game will be over. There we go. See? It times out and it stops. Is that the way it's supposed to be? I tend to think it is, because it's different. Well, now it's actually going again. So maybe it stops and starts like this. I don't know. It is different though. It is a different behavior. So I think just for comparison's sake, I'm going to put this one back in it and see if it just continuously, the road just continuously rolls. Because I think that's what this is doing, is stopping it from doing that under a track mode. I think. So let's do that. Let's pop this guy back in it. We know this one's bad. Put it back in this spot here and see what happens. See how the road scrolling behaves. Alright, now I put the old one back in, and it's doing the exact same thing. It's doing the same behavior. If I start the thing up, where now we're playing and it's scrolling, so no, I don't know what that does. It doesn't have anything to do with the road though. Yeah, I don't know. But this one I tested it on my good tester and it is definitely no good. I mean, I can remove it and it doesn't make a difference. So I don't even know what that thing does. It's in the circuit right here. Looks like it's having a little control with this thing, which has something to do with the acceleration maybe. I don't know. Who knows? Yeah. Yeah. I mean, we'll leave this thing, we'll leave it completely blank. I'm going to put this one back over here because it is bad. And see if this thing times out. Weird hardware. All TTL hardware. These games that are all TTL like this, yeah, see, it does the same thing. Now if it holds true to form, it'll scroll for a second and then it'll stop again. Yep, and then stop again. Yep. So that's the exact same behavior it's been doing with the other one, so who knows? I really don't know. Is this normal? Or is it supposed to scroll all the time? I don't know. Anyway. Weirdness. Yeah, these games that are made completely of discrete circuitry and all TTL like this, they're just kind of confusing. Every circuit is discretely generated, and it just can be, if it's not well documented, like it's not really well documented on here what is what. I mean, stuff is labeled Excel, but what's that mean, you know? This says other car. What does other car mean? You know, obviously it's not your car, right? But I just wish it was better documented on the schematic about what is doing what, you know. Who knows? But we'll keep plugging away. Keep plugging away on this one and keep trying to find bad parts. Right now I'm on the very final 85 on this board. And since I'm set up to analyze 85s, I'm going to throw the other board from right there. I'm going to put it on here and go over all of the 85s on that board, make sure they're all good. You know, since I'm set up, I'm going to just go ahead and knock them all out. Yeah. Alright, I'll be back. Alright, I'm going through the 85s on this other board. And I came to this one, and this one is no good. If we look, and I have a screenshot up here, where this says 10 up here, I know from doing the other ones automatically that should be on the outputs, that should be 010 all the way, this whole duration. It should be 010. And if we scroll down, it is 110. So this output line right here is stuck high. That whole one right there. This should say 010, and it doesn't. And then when we get here, we have an even. We have where they're all equal. So we move to these, and it's 111. And when they are 111, we should have 001. We should have 001 on the outputs right here. And we have 101. So this bit right here is stuck high. But this one is no good. So I'll move on to this one, and we'll take a look at this one really quick. Give it a screenshot. First, I like to just see I like to just run it and see kind of what frequency it's running at, so I can dial in my frequency to get a good screenshot of it. That seems, we'll go with this right here. Take a screenshot and move up. Here we have this little duration right here. We have 0, 1, so that should be 0, 1, 0 right there. And it is 0, 1, 0. And then we move to here. This whole time, this top line is 1, 0. So this whole time, it should be 0, 1, 0 down here. And it is 0, 1, 0. So we can just move over to our next. Here's our next transition. And it's, okay, now we have 0, 1. And I know just from doing these that that output should be 1, 1, 0 on the bottom. Or should it be 1, 0, 0? It's 1, 0, 0. Let's see what it should be. Yeah, 1, 0, 0. That first line, 1, 0, 0. When A is greater than B, the output should be 1, 0, 0. And A is greater than B right here. So we should have 1, 0, 0, which we do. You see A is greater than B, so we have 1, 0, 0. So that's actually correct. Then if we move to the next possibility, here we have all equal, and we have 1, 1, 0 on the inputs, and 1, 1, 0 on the inputs. Our outputs should be all 0, 0, 0, 0. And they are 0, 0, 0. When it's 1, 1, 0, it's 0, 0, 0. And then it goes to 0, 1, 0. 0, 1, 0. It's a little confusing, I know. But once you do these enough, you kind of get the pattern. So you can actually look at everything and be like, yeah, this is what the output should be according to what it's telling me up here. And this one is good. This one is no good. So I'm going to mark those. This one's bad. And then there's 4 more here and here. And there's one right here too that I'd like to do, but remember it's got that wire. I gotta rearrange the wiring on the back of the board so that I can actually test this one. So I want to test this one because these things, that's a pretty good failure rate. I found 2 bad so far, and I still got 5 to test on this board, and this one I need to test on the other board as well. So yeah, this one needs to be replaced. So I'm gonna mark these and then move on. Okay, just chiming in. I got another one with a stuck bit. This one right here. You see I got this one marked red. This one also has the same stuck bit. Really quick, right here, this little portion right here, this section right here, we have equals. A equaling B, so we move on to our outputs, and they're 1, our inputs. Oops. And our inputs are 1, 1, 1. So according to our table, 1, 1, 1 is right here. Basically, when this last one is 1, it doesn't matter what these ones are. If this one's 1, our outputs should be 0, 0, 1. And you'll see our outputs here are not 0, 0, 1, they're 1, 0, 1. 1, 0, 1 right there. This line should be low. At this pulse, you should have a low pulse right here. And we do not. So that one is no good. And moving on. Okay, I'm getting ready to remove those 2 bad parts. Here, IC 18 and IC 42. And I'm just looking them up on the schematic. Here's 18 and here's 42. It's these 2 85s right here and here. And it looks like they're involved in player positioning maybe? Play V start. PL.-H-ST, is that player horizontal start and player vertical start? I don't know. You know, I don't know. Something to do with the player positioning, maybe. Yeah, I don't know. Player positioning? But anyway, I'm going to replace those two guys. I'm going to remove them, and then we'll go inside and we'll get on the TL866 and we'll put them in there and put them through their paces and just verify that they're bad. I like to do that. When I analyze something and it comes up bad, I like to just verify it in my tester, my logic tester, and test them as bad. And while I got the desoldering stuff all out, I'm going to remove this wire. I'm going to put it on the bottom of the board so that I can put my analyzer on both of these. On this board and the one over there, I'm going to put this wire underneath so that I can put my test clip on this thing and analyze this 85 on both boards. So these things have a pretty high failure rate, which is kind of surprising to me. I don't know. Because they're national semiconductor parts, and they're usually, you know, they're not Fujitsu, so I don't know. Old, just age, I guess. They're aging out. Anyway, okay, I'm going to go ahead and remove those, and I'll get back to you when we're inside on the little laptop and testing these guys out. Alright, on both of these boards I went ahead and placed the wire connecting these two chips on the bottom on both of them. Both of them done the same way. And this one here, I just removed, replaced that wire. So that's that. So I'm going to hook both of these up, analyze this guy, and then we'll go in and test these two. I removed those. I'll go ahead and socket these, put new 85s in this board. And I have 193s. I have surface mount 193s. My 193s. I just have these surface mount ones, so I need to put together I have surface mount PCBs that are adapters, so I need to build one of those to put into here permanent. So I'll do that as well. So let's go ahead. I'll let you know if either of these 85s are bad. I'm going to analyze both of them, and then we'll go in and test these ones out. And soldering up my little adapter for this surface mount part. Microscope comes in handy for that. And I got to clean up my flux. Oops. Yeah. Clean it up a little bit and then solder some leads into this, and that adapts that to a DIP package, a DIP package. Yeah, I made these little adapters. Right. Okay, we're here at the testing station. I got my TL8662 tester, and we're set up for 193s right now because I want to test. This is the new one that I built, 193, and this is one that I had in there. I want to make sure this one's good. Let's do this one first. Put it in the tester, close it up, and hit test, and it passes. No problem. Okay, here's the new one that I built. Put it in there, hit test. No problem. Good to go. Okay, so there's a couple good 193s, and here's those 285s, LS85. So we need to change this to 85, and I love this tester. Down to test, and I just hit test and it fails. You see there's no chip in there. So let's put the first one in. Hit test, fail. It fails. And it's probably failing every time that one line needs to go low. Remember, it's stuck high. The same with this one. Same thing, fail. Yeah. So this thing is a great logic tester. I love having this thing. So too bad these 85s are no good and these 193s are fine. So good to go. Okay, now we're back at it, and I'm testing that 85 that had the wire, and it seems like it just does one thing, and some of these only do one thing. Like these two right here, they only, you know, they're like this. They just have one. They don't change. So this one should be on the output 0, 1, 0 all the time, because right here you always have A being less than B. So the output will be 0, 1, 0 the whole time. So that's okay. That's what it should do. So I'm going to pop the other board on here and test that one out, make sure that it is the same. Oh, and by the way, this is the board that had Crazy Blue, remember? Crazy Blue? Crazy Blue is now working as he should. Yeah, you'll see him every now and again. He comes through. That's Crazy Blue right there, I believe. That was Crazy Blue. That, I thought, that's him. That was Crazy Blue. Yeah, so we fixed Crazy Blue. I'm going to go ahead and pop the other, what I deem to be good board on here. So we should have a working board now, a working set. See, this one had those 285s that were bad. And for whatever reason, I think that was Crazy Blue, I think. I don't know. It's weird. Okay, really quick. I did pop the other board on here because I wanted to test that 85 on this one, and we get the exact same behavior. You see, and our output is 0, 1, 0 the whole time. So exactly the same. So that is going to be good. So all of the 85s are now checked out. And this one, surprisingly enough, you hook this board up to that, and this is the same other board that I just had on it. The color is closer to good, but it's still not right. And that's Crazy Blue right there. You've seen him. He still looks different. He looks goofed up in this one. So this board still has issues. But what I'm going to do is I'm going to put this other board set with the blue sockets, I'm going to put that back on there, and it looked like Crazy Blue was fixed. So I want to check that out. Okay, I put this board back on it, and I flipped the board so that this one is upright. And this is the Crazy Blue board, which the colors look right. But you'll see, here comes Crazy Blue probably, going crazy. And Any second now. Surely any second now. There he goes. There he goes. Acting crazy. Alright. So let's look around on this board for issues. I haven't done anything with this one yet. It needs to be cleaned. I replaced some caps. And I tested all of these socketed 157s, and a few of them have failed, and probably more of them. No, actually, that's the other board that's not scrolling. This one is at least scrolling. And I'm pretty sure that this is what it's supposed to do in attract mode, is scroll. So, yeah, that other one's got some serious issues. This one's got crazy blue going on. I'm going to start looking on this board for that problem. So let's do that. Since this thing's set up for 85s, I'm going to see if there's any of those 85s on this board that I can look at before I, tear that down and move on to something else. Let's see if there's 85s on this board to look at. Here's a little trick for y'all. You've heard me talk about the poor man's comparator. Well, this is a 174, and I've got the output pins pulled up to where I can probe them. Just the output pins are pulled out. What I'm going to do is set this over. I found a bad 174, and I'm going to show you how this guy right here, I got a red mark on it, and I'm going to show you how this works. You just pop this over that chip. Oops. Okay. Like so. And now I'll show you the scope, the little scope. Get you in on the little scope here. And the top two lines are the lines I'm comparing. I'll show you what good lines look like and all of that. And what all I'm doing is the yellow line there, I'm putting on my comparator chip. And the blue I'm putting on the actual pin of the chip itself. So this is one output. Now remember, the chip that I have jumped over the chip is the yellow line. And you see those outputs look, they match. This is just a comparator. I'm using it as a comparator, comparing the outputs. Now I'll move on to the next one. And you see it looks fine. They match. See that? Okay. Next one, I believe this is just a high all the time situation, because the input, you see the input there is floating, so that's okay. Now we'll move on to this side. Blue line is the actual chip being tested. Yellow line is my comparator chip. You can see those are perfect. And move on to the next. Okay. Now you see that blue line is stuck low on this one. These are supposed to match. And they don't. And I will try to back this up so you can get a better view of what I'm doing here. Okay, let's back up so we can get a view of both the chip and the thing back there. Here's the chip. And all I'm doing is putting the blue lead down on the pin itself. The output pin itself, and then putting my yellow lead on my chip jumped over it. That's an input. Okay. And here's the output. You see it matches. And going back to that bad output, here's the blue line on the actual chip, and then the yellow on my chip. Jumped over it. And you can see they don't match, so that's a bad chip. It's just an easy way to do a comparator. Just a little chip with the output pins pulled out so that you can test both the chip being tested and your comparator chip. Kind of slick. Moving on. Oh boy, have I wasted my time. Anyway, I'm getting so frustrated, was getting so frustrated with Crazy Blue. There he is, going crazy. So what I did was, and this is not the Crazy Blue board. That's the Crazy Blue board right there. This is the one that had Crazy Blue just not looking quite right, right? I removed all of the 161s that are these. These are all other car positioning, I believe. All these 161s, 8 of them, 1, 2, 3, 4, 5, 6, 7, 8. I removed all of them. And I labeled them 102, 96, 90, 104, 109, 116. These two right here, 101 and 117, read bad in my reader. But I think they may have gone bad when I removed them, because I just don't think that any of these were actually bad. But anyway, this 161 right here was in this board right here. I had already replaced that. Let me do this. Let me remove this chip. Okay. Now, you'll see a line go up there. There. I don't know if you can see it. See it? There it goes. That's the Crazy Blue line. This chip that I had replaced, this is no good. I put bad chips out of my stock into that board. And I thought I tested that. But maybe that's when I found this thing to be flaky. I don't know. But if I take this one right here, which is a good one, and put in here, now you'll see Crazy Blue. There he is. Now, granted, he looks goofy. See that? But we've made a major breakthrough. That Crazy Blue is right here. That's 117. 117 is right here. So Crazy Blue is probably 116 and 117. 116 and 117. So I want to remove 116 as well. See what happens. Crazy Blue, go away. Just the line now. I gotta wait and see. Okay, I'm not seeing anything now of Crazy Blue. $116. Let's take a look. What's 116? That's the one I removed, right? 116. That's this guy. which makes a signal and then that gives the load command for this. You take this one out, it totally kills Crazy Blue. So we'll put 116 back in the board and we'll get Crazy Blue back. There he is. Yeah, see, he's looking good now. So, that's good. This one didn't have any bad parts on it, but removing those and everything helped me find the bad one on here that I had replaced with a bad part. Darn it. So I'm going to put this board back on, put a good 161 in that, and we should have a good looking Crazy Blue. Okay, I put this board back on, put a good 161 in it. Here's the bad one that I had put in there. Unbelievable. And check out Crazy Blue. There he is. Looking perfect. And actually looks right in this one. Yeah, and the good news is this is the board. This is the background board that was messed up, that I found a few bad parts on and replaced. There's Crazy Blue. He looks perfect. There he is. Heck yeah. This one's looking really good now. Yeah, this is that board that had the bad 174 on it. And I found a couple bad 157s on it. So that appears to be working good now. And this board is working good. We have a working set. There's Crazy Blue. He looks perfect. See that? He's no longer freaking out. There he goes. There he goes. There he is. Crazy Blue. Yay. All that time over a bad part that I put in the board. Damn it. That's so irritating. So this set's good. This board goes along with that board, the two blue socket boards. So I'm going to go ahead and put the other one on there. And that's a complete set. I'm going to let that one run, because that one's done. This other set, this is part of the other set, remember. The other set just has Crazy Blue looking weird, remember? Now I know what circuit Crazy Blue is. It should be easy to find what's up with him. So, yeah. Let me put the other board on here. We're going to let that one run. I'll be back in a sec. Okay, now we're hooked back up. The blue socket set. Blue sockets and blue sockets. This is the blue socket set. And here we are. There we go. Blue socket set. There's Crazy Blue. Yepper. Okie doke. I'm going to let this set run for a little bit. This board set has been running while I've been testing. I've probably tested this set for 6 hours. I would say maybe more than that. Just in troubleshooting and testing. So I'm pretty confident that this thing is pretty good, has a pretty good burn in, a pretty good runtime in. So happy with that. This one, I had to replace a bipolar. Remember that bipolar did not match the set. We got a 190, what is that? 85 here. 161. I cleaned this board really good. There's a few chips here, a couple 193s and another 85. This board had 3 157s fail. And anything else? I don't remember. I recapped the thing, recapped both boards, all the electrolytics. Yeah, so good deal. We'll let this one run. I'm gonna end this one right here, and maybe I'll do like an addendum or something for when I find out what is making Crazy Blue not look right on the other board over there. But as for this one is done and I'm finished with it. So that's it. Everybody, thanks for watching. Shout out to all the Patreon supporters, as always. Appreciate you all. Your continued support helps me continue to keep doing this and putting these videos out. I appreciate it. Thanks for watching, everyone, and we'll see you on the next one. Bye for now. Well, I thought I was done, but I'm not done. I came back out and I noticed a couple, well, I noticed one thing right here. You can see it. See that? See that strip of light? That's incorrect. That failed on me. And I noticed that when I started a game, and this may have been this way the whole time, I'm not exactly sure, but when you started a game, it would never end. It'd never time out. And it turned out this 555 timer, when you start a game, it starts a square wave. It starts going up and down, and it times and clocks these two 192s down here. Well, this thing wasn't toggling. So I replaced it. Now you start a game, it toggles and it counts and it stops the game. See, I'll go ahead and start a game. There it goes. See, the game is started now. And it will time out eventually. We'll come back to it, but I can set this back to, ooh, I don't want that to break. But, yeah, so another thing with that light, I don't think we're ever going to get there until this time's out. Yeah, But, yeah, this is that timer in that circuit. And when the game starts, it sends a high pulse, or a high logic level high to this, and it turns this on and it counts. And these counters are what count down the time. And the lights, there's this light signal right here. Light. And it comes from this 279, which is it's a SR, it's just a set reset latch, basically. A little, yeah, you know, gets a set or a reset, and it sets Q or resets Q, basically. Anyway, that thing, and you can see right here we have timed out. And this thing should start scrolling. Yeah, there it goes. You know, that is working properly. But this is that chip, right? This is that 279. You can see I got it marked red. If I take a 279 and I pop over it, now we will wait for the darkness to show up, and it won't have that line in it. We'll get there eventually. There it is. See, there's no line anymore. Remember, it had the whole light line going all the way up and down. So that fixed that. I'll show you what I mean once more before I end the video. We'll remove that. Now when the dark comes and the light comes on, you'll see the headlight, the headlight, and then there's a strip of light all the way across the screen on the road. So we got to wait for the darkness to show back up, and you'll see it. And it's that that latch chip that fixes that. It's just that light signal. Here's the tunnel. This is a cool game. I would love to play this. And see that light? The light strip? Yeah. So I will replace that 279 right here, and that'll fix that. Be right back. Okay, the 279 permanently installed, and let's wait for the darkness. So since I stopped the video before, I fixed the timing issue for the gameplay time, and we had this failure occur for the lighting, and now it's even goofier. Check that out. Interesting. What in the world was that all about? Huh. Well, let me put another 279 in there, and I don't know. We'll see. I'll be right back. Alright, well, I discovered, I tried a different light ROM from the other board, and that was not the problem. It's not the ROM. It's in the circuitry somehow, and this 279, this chip right here, I found that I can get varying degrees of success by using different chips. And I found that I can get complete success by jumping a chip over a chip. So I took it a step further, and I just soldered a chip onto the chip, onto another chip. And that fixes it. Yeah, I don't know. It's weird. Is it the spec of the chip? Is it circuitry feeding the chip? It's not the 85s. I checked the 85s. I reanalyzed these two 85s, and they were fine. That was not the issue. I figured maybe it's the ROM that is feeding into the 85s, and it's not the ROM. I thought maybe it's the addressing to the ROM. It wasn't the 93 addressing it. It could still possibly be something funky in here, but this, you know, this circuitry right here, I didn't fully analyze. This block right here that feeds into all of that, which could have something to do with it. There could be a flaky signal, but I find that this is a fix right there. No more weird No more weird lines. Yeah, just introducing some kind of capacitance into the circuitry or something like that, just with that chip on top of the chip, fixes it. I don't know exactly why, but whatever. It works. I'm recalling it good. Check out that lighting one more time before we sign off. It should be coming up after the tunnel. And now we got this. And there it is. There's your light. Nope. Alright, now we're going to call it good. And as always, thank you to all the Patreon supporters who continuously support the channel and help me continue to keep fixing this old stuff and putting videos up like this. I mean, your support is greatly appreciated and it really keeps this rolling. So, alright. Thank you, everybody. We'll see you next time on Classic Arcade Repairs. Bye for now.